All right, this is a question from homework 52. This is problem number 10. So the instructions are to prove or disprove the statement. So for 10, it's saying, for A, it's saying the point -4, 8 lies on the circle centered at the origin with a radius of 4√5. So here, what helps me is just visualizing it. So I could sketch out coordinate plane centered at the origin. So here's my X marks the spot right there. And a point of -4, 8 would be right about here. Okay, so then I'm going to draw a circle like that. Remember that that point was -4, 8. So if I make a right triangle out of it, like so, this leg would be 4 units, this leg would be 8 units. So I need to make sure that right here that my radius turns out to be 4√5. So I'm just looking at, is x squared plus y squared equal to my radius squared? So let's solve for the radius here and confirm or not that it's 4√5. So if I plug in 4 squared plus 8 squared equals r squared. 16 plus 64 equals r squared. So my radius squared equals 80. And if I solve by taking the square root, 80 is 16 times 5. So I would get plus or minus 4√5. My radius has to be the positive. So my radius would have to be 4√5. So I've proven that a point -4, 8 does lie on a circle centered at the origin with a radius of 4√5. So we'd say proven. We've proven it because the statement itself is true. Okay, and then for B, similar idea. Here it's telling us that the point √10, 3 lies on the circle centered at the origin and contains the point 4√3. Okay. All right, so √10, 3 and 4√3. So let's try the same strategy. Let's draw a little coordinate plane. So here for my first triangle, √10, right, that's a little bit more than √9. So it must be 3 and a little change. So I'm going to go here from the origin. There's my X marks the spot. I'm going to go right a little over 3 and up 3. So we'll say about right there. So right here is my √10, 3 point. And then 4, √3, well, √3 is just under √4, so it has to be just a smidge below 2. So here I'll mark this with a different color. We're saying about right 4 and up √3, so a little more than 2, so we'll say right about there, about. Okay, so then if I draw my circle, right, I'm looking at a circle roughly like this, and I'm picturing those two triangles. So here was the first one, where this is the √10 and this is the 3. And here is the second one, about like that. Where here is the 4 and here's the √3. So we want to see again if they have radii that match, right? They need to have the same radius. So if I go through Pythagorean theorem, so √10 squared plus 3 squared equals r squared. So squaring a square root becomes just then 10. 10 plus 9 equals the radius squared. Radius squared is 19. Take that square root. We know it could be plus or minus the square root of 19, but has to be the positive because it's a measurement. So the radius would have to be the square root of 19. And then over here, we need it to match to prove it true. So 4 squared plus √3 squared equals the radius squared. So 16 plus 3 equals the radius squared. Radius squared is 19. We see that the radius will be the square root of 19 here as well. So again, this one would also be proven. We have proven that it is true. Again, because the radii match. We know that here, with that given point, the radius is the square root of 19. With this given point, the radius was also the square root of 19. So they must be points on the same circle with the center at the origin. I hope this helps. Have a good day.